Today's topic is Atoms and Molecules, Class 9, Chapter 3. Around 500 BC, Indian philosopher Maharishi Kannad postulated the theory that if we go on dividing matter, Padarth, we will obtain smallest particles beyond which further division cannot be possible. This is known as Parmanu. Ancient Greek philosophers, Democritus, Leucippus, called these particles as atoms. Antonio L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. Laws of chemical combination. This law was established after the experiments by Lavoisier and Joseph L. Proust. The chemical reaction between two or more substances give rise to products which is given by certain laws called laws of chemical combination. So there are 5 types of laws of chemical combination: law of conservation of mass, law of constant proportion, law of multiple proportion, law of reciprocal proportion, and Gay-Lussac's law of gaseous volume. The last 3 we will study in the higher classes. So we will study only the first 2. First is the law of conservation of mass. During a chemical reaction, the total mass of the reactants will be equal to the total mass of the products. Mass can neither be created nor be destroyed in a chemical reaction. For example, a reactant A and B give rise to a product AB where mass of A and mass of B will be equal to the mass of AB. Like log plus fire give ashes and smoke, and both sides the mass is equal. Law of constant proportion. In a chemical reaction, compounds always contain the same elements present in a definite proportion by mass irrespective of their source. For example, 18 grams of water gives 2 grams of hydrogen and 16 grams of oxygen. So the mass of hydrogen upon the mass of oxygen, that is 2 by 16, will be 1 by 8. Similarly, 36 grams of water gives 4 grams of hydrogen and 32 grams of oxygen. Here also, if we divide the mass, we get 4 by 32 or 1 by 8. Similarly, for 9 grams of water, 1 is equals to 1 grams of hydrogen and 8 grams of oxygen. Here also, the ratio between hydrogen and oxygen is 1 by 8 only. This verifies laws of constant proportion as the ratio of mass of hydrogen to oxygen is always the same. Dalton's atomic theory. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. 6 postulates of Dalton's atomic theory. All matter is made up of tiny particles called atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties, which is the law of conservation of mass. Atoms of different elements have different masses and chemical properties. Atoms combine in a ratio of small whole numbers to form compound, which is the law of constant proportion. The relative number and the kinds of atoms are constant in a given compound. What is an atom? Atoms are the building blocks of all matter. According to modern atomic theory, an atom is the smallest particle of an element which take part in a chemical reaction. Atoms are very small and cannot be seen even through very powerful microscope. Atomic radius is measured in nanometers, which is 1 nanometer is equal to 10 to the power minus 9 meter. Here are some examples of the radius of different elements. Modern day symbols of elements. Dalton was the first scientist to use symbols for the elements. Here is a list of the symbols that are given by Dalton. Berzelius suggested that the symbols of the element should be made from 1 or 2 letters of the name of the element. Earlier, the names of the elements were derived from the name of the place where they were found for the first time. For example, the name of copper was taken from Cyprus, a place it was first found. Nowadays we use IUPAC numbering, that is International Union of Pure and Applied Chemistry, which is an international scientific organization which approves the names of elements. According to IUPAC naming, the first letter of the symbol is always written as a capital letter and the second letter as a small letter. For example, hydrogen H, aluminum Al and cobalt CO. Some other symbols have been taken from the names of elements in Latin, German or Greek. For example, iron is taken from its Latin name ferrum, sodium is taken from natrium, potassium, K is taken from kalium. Atomic mass. Dalton's atomic theory suggested that each element has a distinguishing atomic mass. With this theory, the law of constant proportion could be easily explained. But it is indeed difficult to evaluate the mass of an atom since the size of atom is relatively small. So therefore, the scientists started evaluating the mass of an atom by comparing it with the mass of standard atom. Earlier, 1/16 of a mass of oxygen atom was used as a standard for calculating the masses of other elements. But nowadays, carbon-12 is considered as a standard atom for calculating the masses. So we can say that the mass of an atom of an element is called its atomic mass. IUPAC have accepted atomic mass unit U to express atomic and molecular mass of elements and compounds. The atomic mass unit is defined as the quantity of mass equal to 1/12 of the mass of an atom of carbon-12. So 1 AMU or U is 1/12 of multiplied by mass of carbon-12, which is equals to 1.66 into 10 to the power minus 27 kilograms. Here is the list of atomic mass of some of the elements. You can pause the video and take a look. How do atoms exist? Atoms of most of the elements are very reactive and does not exist in free state. Only atoms of noble gases, that is helium, neon or argon, are chemically unreactive and exist in free state. Atoms cannot survive independently, so they join together and form molecules or ions. Molecules. A molecule is a collection of various atoms that combine chemically with each other. These atoms are bound together by a certain force of attraction. Atoms of same elements or different elements can bind together to form molecules. Therefore, a molecule is a small particle of a substance that can exist independently and shows all properties of that substance. Molecules of elements. The molecules of an element are formed by the combination of similar type of atoms. For example, helium is made up of only one atom, oxygen is made up of two atoms. Atomicity. The number of atoms in a molecule of an element is called its atomicity. For example, helium is monoatomic, oxygen is diatomic. Monoatomic. When an element comprises a single atom, example all metals, they are monoatomic. Diatomics are when the elements comprises two atoms, like all the gases. Triatomic when the elements comprises three atoms. Tetra when they comprises four atoms. And polyatomic is when the elements comprises two or more atoms. Molecules of compound. The molecules of compound constitute atoms of different elements that combine together in a fixed proportion. Here you can say water comprises of two atoms of hydrogen and one atom of oxygen. Methane comprises of four atoms of hydrogen and one atom of carbon. Ions. Compound contains metal as well as non-metals. These elements include charged species which are known as ions. Thus, an ion is a particle that has positive or negative charge. Anions are negatively charged and cations are positively charged ions. There can be single charged atoms in an ion. For example, hydrogen +1, chlorine -1, sodium +1. Or there may be group of charged atoms in an ion that have a net charge of the compound. For example, carbonate, which is CO2, which has the charge of 2 plus 2. When a group of atoms carries a charge in a compound, it is called a polyatomic ion. Chemical formula. Chemical formula is a symbolic representation of the composition of the compound. To write a chemical formula, you must know two things. First is the symbol of the element and second is the valency. What is valency? It is the combining capacity of an element with the other element. Here is a list of valencies of various elements. You can pause the video to take a look on these valencies. Rules of writing a chemical formula. First, write the symbol of these elements which form compound. Below the symbol of each element, write their valency. Now cross over the valencies of the combining atoms. Now let's take an example. We write symbols H and S. We have valency of H is 1 and S is 2. Now we are crossing over. So we'll get H2S1, which can be written as H2S, which is hydrogen sulfide. Let's take another example. Symbol C and O. C has a valency 4, O valency is 2. So now combining, crossing over, we get C2O4. So cancelling out, we can get CO2, which is carbon dioxide. Similarly, for aluminium and oxygen with valencies 3 and 2 respectively, we get Al2O3, which is aluminium oxide. Molecular mass. It is the sum of atomic masses of all the atoms in a molecule of that substance. For example, molecular mass of water is equals to 2 multiplied by atomic mass of hydrogen plus 1 multiplied by atomic mass of oxygen. Now we know that atomic mass of hydrogen is 1 unit and atomic mass of oxygen is 16 U. So now putting the values over here, we have 2 molecules of hydrogen and 1 of oxygen. So we'll get 18 U. Formula unit mass. It is the sum of atomic masses of all the atoms in the formula unit of a compound. The formula unit mass is used in case of substance that constitute iron. For example, atomic mass of sodium is 23 AMU, atomic mass of chlorine is 35.5 AMU. So, the formula unit mass of sodium chloride will be, because both the molecules have 1, so 1 into 23 plus 1 into 35.5, we get 58.5 units. Mole concept. Let's take a chemical equation. 2 carbon plus 1 oxygen atom gives 2 carbon dioxide atoms. So now we can say that 2 molecules of carbon combined with 1 molecule of oxygen to form 2 molecules of carbon dioxide. Or we can say 24 units of carbon molecules combined with 32 units of oxygen molecule to give 56 units of carbon dioxide molecules. Therefore, we can characterize the quantity of a substance by its mass or by its number of molecules. A chemical equation directly indicates the number of molecules participating in the reaction. Thus, it is convenient for us to refer the number of substances in a chemical reaction as the number of moles of atoms. Mole. Mole is a numerical quantity that has a mass equal to the atomic or molecular mass of atom, molecule, ion or any particle. A mole of any substance is equals to 6.022 into 10 to the power 23 number of particles, atom, ion or molecule. This is Avogadro's number, also known as Avogadro's constant, and represented by NO. So the atomic mass of a substance when expressed in grams is known as its gram atomic mass. The molecular mass of a substance when expressed in gram is known as gram molecular mass. For example, atomic mass of sulfur is 32 and grams, and atomic mass of sulfur is 32 grams or 32 unit we can write. Also, 32 unit of sulfur has 1 atom of sulfur, 32 grams of sulfur has 1 mole, which is equals to 6.022 into 10 to the power 23 atoms of sulfur. So 1 mole is equals to 6.022 10 to the power 23 number. Wilmot Oswald introduced the word mole, which means a heap or a pile. Therefore, we consider a substance as a heap of atoms or a molecule. Important formula. Number of moles is equals to mass of a substance upon molar mass. Number of moles is equals to number of particles upon Avogadro's number. Let's have a quick review of how mole, Avogadro number and mass are related to each other. Here you can pause the video and take a look on